Hello, welcome everyone. In this video, I'm going to work out an example by using the difference of derivative property. Okay, so we have a function which is the difference of two terms. So by using this property, the derivative of this function is going to be the difference of the derivatives of those two terms. So if we have a function which is the difference of two terms, when we take the derivative of that function, then the derivative is going to be the difference of the derivatives of those two terms. So this is our example, this example function, and we are going to use this property to solve this one right here. So when we take the derivative of this function, so it's going to be equal to d over dx of square root of 8x minus 2 over cube root of 5x. Okay, so derivative of these two terms is going to be the derivative of each independent term and then the minus sign in between them. We are taking the difference of these two terms. So in the derivative, this is going to hold as well, square root of 8x minus derivative of 2 over cube root of 5x. Okay, so when we use this property here on this function, this is what we get, the difference of the derivatives of each term. And now we can go ahead and simplify it further. We know that I'm gonna substitute the roots. I'm gonna substitute the exponents for the roots. So we know that square root by itself is something raised to 1/2 power. So I'm just gonna use this exponent sign raised to 1/2, and a cube root is then this exponent sign raised to the 1/3. So I'm going to go ahead and make a substitution for that. So we have d over dx, and instead of square root of 8x, I'm going to write it as 8x to the 1/2 minus d over dx, and we have 2 over 5x to the 1/3 power. Okay, so I just basically substituted the actual value of the root sign. And okay, let's go ahead and solve it further. So I have d over dx of 8x to the 1/2 minus d over dx, the derivative, that's what d over dx stands for, over 2 over, let me see what we have here, 5x to the 3rd power, 5x to the 1/3 power. Okay, now in the next step, what I'm gonna do, I'm gonna separate these quantities inside. We can write them when they're multiplying. We can write them separately. So this is 8 to the 1/2 times x to the 1/2. So I just separated these quantities inside. Since they're multiplying and they're raised to the 1/2 power, you can write them individually as a multiplication like this form, minus d over dx, and you have 2 over, and you can do the same thing in the denominator, 5 to the 1/3 times x to the 1/3. Okay, and you take the derivative of that. Okay, in the next step, I'm gonna go ahead and take out the constant terms from the derivative. I'm gonna take them out. So we can take 8 to the 1/2 outside of the derivative, and then we are left with just the variable term, minus, we can take this out, 2 over 5 to the 1/3, and times d over dx of 1 over x to the 1 cube. That's left inside. So this term is left inside. This one is outside of the derivative. And here I'm going to use another property. Whenever we have x raised to something, let's say x raised to the 1/3, we can also write it as so we have 1 over x to the 1/3. Okay, it's the same as 1 over x to the negative 1/3, or if you have 1 over x to the 1/3, you can write it as x to the negative 1/3. So you can switch their positions from denominator into numerator and change the sign of their exponents. This is one of the laws of exponents. So I'm going to go ahead and do that. I'm going to bring this into the numerator and change its sign to negative. So let's go ahead in the next step. So we have 8 to the 1/2 power times d over dx of x to the 1/2 power. Then we have minus 2 over cube root of 5, so 2 over cube root of 5 to the 1/3 times d over dx, and then I'm going to write it as x to the minus 1/3. Okay, so I brought the denominator into the numerator and wrote it as x to the negative 1/3. Now we can go ahead and take the derivative now, since everything is simplified. So this is I'm gonna for the numbers, I'm just gonna put like a square root on it instead of writing the exponent form. It looks better that way. And now let's go ahead and take the derivative of this. We can use the power property of the derivative, so we can bring the exponent to the front and multiply, and then x to the 1/2 minus 1 minus 2 over, I'm also going to write cube root for this in this form instead of this one. It looks a little better in this form, times, I'm going to take the derivative of this, so we bring this negative 1/3 to the front and multiply with x to the negative 1/3 minus 1. Okay, now we have square root of 8 times 1 is just square root of 8 divided by 2, and x to the 1/2 minus 1 is x to the negative 1/2, and this minus times this negative times negative becomes positive now. So you have 2 over, we're just multiplying here, so this 3 multiplies with cube root of 5, and this is x to the negative 1/3 minus 1 is x to the negative 4/3. Okay, now you can simplify it further, like you have negative exponents, you can bring them into denominator, make them positive. So we have square root of 8 over 2 times, and this thing we can bring it in denominator and change the sign of the exponent, so make it 1/2 plus 2 over 3 times cube root of 5 times, we can bring this in denominator as well and make it a positive exponent. Here we go, and this is your final answer. So this would be the end of this example. If you like my content, please like my video and subscribe my channel. Thank you.